Here's something that might reframe how you think about AI and software. The bottleneck isn't the models anymore, it's you. That idea comes from Alvoeiro at Factory, and it's the foundation of something genuinely interesting in how they've built their multi-agent system called missions. The claim is that human attention is now the scarce resource in software engineering, not intelligence. Models are capable enough. What limits output is how many things a person can actually track, approve, and care about at once. Factory's answer to that is an architecture designed to run for days, sometimes weeks, largely on its own, expanding what a small team can execute in parallel from roughly 10 work streams to 30. So how does that actually work? At its core, missions uses 3 roles: an orchestrator, workers, and validators. The orchestrator does the planning and scoping. Workers do the implementation. Validators check whether the work is correct. Simple enough in concept, but the details of how these roles interact are where things get interesting. Before any code gets written, validation contracts are defined. That's the key move, not tests written after the fact to confirm what the code does, but acceptance criteria written up front to define what correct behavior actually looks like, independent of any implementation. There's a pointed observation here worth sitting with. Validations written after implementation don't catch bugs, they confirm decisions. When you write a test after you've already written the code, you're essentially asking the code to describe itself. Writing validation first forces a genuine standard of correctness. 2 types of validators run at each milestone in a mission. The first is a scrutiny validator, automated tests, type checking, code review agents, the kind of thing most teams are familiar with. The second is a user testing validator that actually spawns the live application and interacts with it the way a real user would, using computer use. That second type is slower and more expensive, and it eats up most of the wall clock time in a run. But it catches things the first type never would. One of the more counterintuitive choices in this architecture is that it runs serially rather than in parallel. Multiple agents working on the same codebase simultaneously sounds faster on paper, but in practice they conflict with each other, duplicate work, and make inconsistent architectural decisions. Parallelism inside missions is reserved for read-only tasks, searching the codebase, reviewing code, things that don't change state. For anything that writes, it's one agent at a time. What keeps a long serial run from going off the rails is structured handoffs. When one agent hands off to the next, it captures what was done, what wasn't finished, every command that was run, exit codes, and any issues discovered along the way. That structured record is what allows the system to self-heal over multi-day runs. There's no hope without it. Another decision that seems small but matters a lot: different models for different roles. Planning requires slow, careful reasoning. Implementation benefits from fast, creative code fluency. Validation needs precise instruction following. No single model is best at all 3, and defaulting to one provider for everything is leaving capability on the table. There's also a subtler argument for using a completely different provider for validation specifically, to avoid a situation where the implementation model and the validation model share training data and therefore share blind spots. The whole orchestration logic, by the way, is defined in roughly 700 lines of plain text prompts rather than hard-coded logic. That means when models get better, which they do, constantly, the system improves automatically. You're not locked into an architecture that becomes obsolete the moment a new model drops. The production results from running this on a Slack clone are striking. About 60% of time and tokens went to implementation. Validation rarely passed on the first attempt, which is actually what you want. It means the validators are doing real work. Half of the final codebase was tests. Test coverage hit 90%. The longest single mission ran 16 days. The team thinks 30-day runs are achievable with what they have now. There's a line from the talk that ties it together cleanly. Missions ensure the discipline, and the models provide the intelligence. The architecture isn't trying to replace judgment, it's trying to protect it from being consumed by the 1,000 small decisions that shouldn't require a human at all. The real insight here is that building AI systems that scale isn't about finding smarter models. It's about designing the structure that lets less than perfect models stay reliable over time.